The second half of section 4.1, we're going to talk about different ways to classify triangles and properties of different triangles. The first way we can classify triangles, is by angles. We have acute triangles where all three angles are acute. They're all three less than 90. We have right triangles that have just one right angle, one 90-degree angle. The other two must be acute for it to add up to 180. We have obtuse triangles that have one obtuse angle, one angle larger than 90. And we have equiangular triangles where all three angles are congruent. They're all 60 degrees. It's very important that you know these words are the triangles by angles, because I will ask you two different ways. I will ask you to classify triangles by angles using the words acute, right, obtuse, equiangular. And I will ask you to classify triangles by sides. When you're classifying by sides, it's based on how many sides are the same or congruent. A scalene triangle has no sides that are congruent. All the sides have different lengths. Usually if a triangle is drawn and there's no marks to show congruence, then it's not an assumption to think that all of those are different. An isosceles triangle has at least two sides congruent. We're going to be using the word isosceles for exactly two sides congruent because when all three are the same, we have the word equilateral. You do need to know that the actual definition of isosceles says at least two sides are congruent, whereas we'll be using the word more to describe when exactly two sides are congruent, because if all three are the same, then we'll use the word equilateral. So this middle picture goes with isosceles, single slash on two different sides, those are the same. This bottom picture, single slash on all three sides, all three are the same. That's an equilateral triangle. Very important that however the sides match up, the angles must do the same. For example, if there are two congruent sides, there will be two congruent angles. If it's equilateral and all three sides are the same, then all three angles will also be the same. Let's look at two specific types of triangles. The first one is a right triangle, and we're going to talk about the parts of the right triangle. In my right triangle, I can have one right angle. These other two must be acute. They must add up to 90 degrees. Opposite means across from my right angle. This long side is the hypotenuse. It's always the one that's slanted. The two sides that make up the right angle are called the legs. The other triangle we're specifically going to talk about is called an isosceles triangle. And again, isosceles means at least two sides are congruent. We're going to use this for exactly two sides. So I'm going to mark these two sides, AB and CB, single slashes, those are congruent. The two sides that are congruent are called the legs. So the legs are the two congruent sides. So here, segment AB and segment CB. The base is the side that's not congruent. Now up against the base, you have two base angles. These will be congruent. And the reason for that is because opposite a congruent side are congruent angles. So if you go across from this mark, opposite that is an angle, that across from this mark, opposite that is a congruent angle. So that's what these single arcs mean. Those are showing that these angles are congruent. The other angle where the legs meet is called the vertex angle. This is the one that's not congruent, and it's opposite the base. So base angles are the two congruent angles. They're opposite the congruent sides. The vertex angle is opposite the base, and it's not congruent. I have two congruent sides. I'll only have two congruent angles. We have a corollary. Remember, corollaries follow from theorems or definitions. This corollary says if two angles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. This is also called the third angles theorem. So if I have this triangle and another triangle, and I tell you that these two bottom angles, single arcs, those are the same, and these kind of top left angles, double marks, those are the same. Because they both have to add up to 180 and two pairs of angles are congruent, then this third pair of angles must also be congruent. There's another corollary that states that each angle of an equiangular triangle has a measure of 60 degrees. That makes sense. My whole triangle is 180. So if all three angles are the same, 180 divided by 3 means each one is 60. Another corollary states that in a triangle, there can be at most one right angle or one obtuse angle. That makes sense because if I had two right angles, that would be 180 degrees, and there wouldn't be any left for a third angle. If I had two obtuse angles, then I would be over 180. So you can only have one obtuse angle or one right angle in any triangle. All of our triangles still add up to 180 degrees. We're going to work through some examples using what we know about the isosceles triangle. Most of our examples will be about isosceles. So number 1 says that segment AB, so I'm going to put a single slash on that, is congruent to segment CB, so I'm going to put another single slash. Now, we know that however many sides are congruent, that many angles are congruent. So we want to stop and mark our base angles. It's really important that you draw a picture for every problem and make the congruence mark so you can see what's happening. My first base angle would be opposite this mark, C, and then opposite this mark at A. The other thing you can do is the two that are congruent are the legs, the third side is the base, the two angles that touch the base are congruent. Then they tell us that the measure of angle A is 50. We need the measure of angle C and the measure of angle B. Since A and C are congruent, C is also going to be 50. Then I know my whole triangle adds up to 180. So 50 plus 50 is 100. 180 minus 100 means that angle B is 80 degrees. Okay, we're just going to walk back through this. Because we had these two congruent sides, I have two congruent angles. So since they told me A was 50, C is also 50. Because the ones that are congruent are the legs, this third side is the base, and it's the two that touch the base. Those are always going to be congruent in our isosceles triangle. To find the third side B, we added up 50 plus 50 and got 100, and then 180 the whole triangle minus the 100 left 80 degrees for angle B. Now when I move to a new problem, I'm going to draw a new picture. So we're going to draw a new picture. I'm going to erase all my marks. I don't know anything to start. This one says that segment AB, so segment AB, the side, is congruent to segment AC, the bottom side. Now remember, when you have these segment marks, those are sides of the triangle, so you're putting these slashes through. So AB and AC, those are the legs, which means this third side, BC, is the base. So the two angles that touch the base, my base angles, are congruent. So this time, B and C are congruent. This is why it's very important to draw a picture with every problem so you can visually see which sides and which angles are the same. This one says the measure of angle C is 40 degrees. Automatically I know B is congruent to that, so that's also 40. And again, to find the third angle, we're going to use 180. So 40 plus 40 is 80. 180 minus 80 leaves 100 degrees for angle A. These all look like they're acute angles. It's okay that angle A is obtuse. This isn't drawn to scale, it's just drawn to be a representation so you know where the letters are. Make sure you draw your picture exactly the same as the one that's already on the screen so you have the letters in the correct place. Let's try a couple more. You can also do this kind of vice versa. So if the angle A, we're going to put an arc there, a single arc, is congruent to angle B. 3 says A is congruent to B. We were given that information, so I'm going to put a single arc on B. If I have two angles congruent, I also have to have two sides congruent. So again, these two angles, these are called base angles. They touch the base. It's the other two sides that are going to be congruent, the ones opposite of A and opposite of B. Then it says AC equals 9. Find BC. Well, I know these two are congruent. I put my single slashes there. So if AC is 9, BC must also be 9. Okay, let's try one more. Again, we're going to redraw our picture, and I'll have you do this for the test. We're going to need paper, and we're going to draw pictures so we can see the congruences. Number 4 says angle A is congruent to angle B. Again, those are base angles. This is my base. It's the other two sides that are congruent. AC is 3x plus 7 BC is 5x minus 1, just straight from our problem down here. That's what they told us. Since these are the two that we marked, those sides are exactly the same. They're going to be equal to each other. So we're going to set 3x plus 7 equal to 5x minus 1, and we're going to solve. I'm going to subtract my 3x because it's the smaller x, and I will get a nice positive answer. If you're a person that likes to have all your x's to the left, go ahead and solve the way you would like, and we should all get the same answer. All of my x's are to the right, so I'm going to add 1. 2x equals 8, and if we divide by 2, x is 4. Now, I'm always going to ask you to plug back in. So if we look, they want the length of AC. Remember, not having the symbol means the length. So I'm going to do 3 times the 4 plus 7 because we're plugging in to AC. 3 times 4 is 12 plus 7 means that AC is 19. I could double check this. BC is supposed to be the same length, so I could plug it in. 5 times 4 is 20 minus 1 is also 19. That's just a way to make sure you got it correct. We're also going to work some examples using what's called the expanded picture. This is the one where the exterior angles are not only drawn from one side, but actually all three sides. So we have our interior angles, 2, 4, and 6. Our exterior angles, 1, 3, and 5. And we still know 2, 4, and 6 all add up to 180 inside the triangle. That an exterior, like angle 1, and the adjacent interior, angle 2, those add up to 180. And we know that any exterior, such as angle 1, is equal to the sum of the two remote interiors. The two interior angles that are far away, if I add them up, I'll get angle 1. So 1 would be 4 plus 6. Angle 3 would be 2 plus 6. Angle 5 would be 2 plus 4. Now, we're going to give you a little more information with this expanded picture and all that information that you already have from the first half of the chapter. We're given that segment AB, so AB, that's the bottom, is congruent to segment AC. AC is the left side, and you want to read those carefully. Make sure your marks are in the right place. This is an isosceles triangle. If I have two sides the same, I should have two angles the same. So these are my legs. My third side is the base, and it's the two angles up against the base that are congruent. There will be problems on the test you will not be able to answer without knowing this. Since this is given for the picture, I can leave these marks on for all of my problems, and this will be true. The thing that's going to change is what angles they give me, so I'm going to put those in red. This one says the measure of angle 1 is 140. Find the measure of angle 6. Well, I know that angle 1, this exterior angle, is the same as my two remote interiors added together. It's the same as 4 plus 6. Since 4 and 6 are congruent, they're each half of the 140. So angle 6 is 70 degrees. Now, if I had forgotten about that, there are some other ways to figure this out. 1 and 2 add up to 180, so 180 minus 140 means 2 is 40 degrees. My 180 triangle minus that 40 means that 4 and 6 together are 140, and since they're congruent, I can just divide it by 2 and I'll still get 70 degrees. When I change problems, I'm going to take away the 140 and the 40 degrees. I do still know that 4 and 6 are the same because my given information off to the side is true for every problem. Number 2 says that the measure of angle 4 is 59 degrees. Find the measure of angle 5. Well, if 4 is 59, 6 is the other base angle, they're congruent, so 6 is also 59. But 5 and 6 are adjacent, they add up to 180. So angle 5 will be 180 minus 59. And if we subtract, we get 121 degrees. Now again, I'm going to go ahead and erase the new information, the 59, but I do still know that these two sides and these two angles are congruent because that was my given information for all of these problems. Number 3 says the measure of angle 6 is 32 degrees. Find the measure of angle 2. I'm going to start with the obvious one. I know if 6 is 32, 4 must also be 32. But I know that my whole triangle is 180. So 32 plus 32 is 64. 180 minus 64 tells me that it's 116 degrees. So angle 2 is 116 because the interior of my triangle has to add up to 180. When you come into class, we're going to do handout 4C and 4D. And for this term, the test will be Friday.